As mentioned, this topic, or this part of the topic, sorry, is part of the Band 6 questions that you're going to see in your HSC. So everything you're going to learn in Year 12 to be Band 6 quality stuff. You just integrate, you differentiate, whatever, not going to be hard. These bits, this bit, superannuation and loan payments, max-min problems are bad. That means as much as you can for this next whole year, if you can just keep working on them, maybe a question a week, like we're going to do for prelims, just do a question a week on these, wow. You're going to be a force to be reckoned with. Seriously though. Important it is to perfect these two concepts. So series and sequence, the last bit of it, and max-min problems. Everyone gets that stat points, you know, points of inflections, graphing them. Most of the state are going to get them right. This bit, the formulas, once you know the beginning, most of the state are going to get it right. It's this part, a lot of students just cannot wrap their head, especially if your teacher's getting before me, then they're going to confuse the hell out of you, and then you're going to look at this becoming really, really hard. As with every topic, I always, if there's something that is done differently, I do this bit a little bit differently to your teachers. So if you do understand it, just go back to the recording then. Easy. Don't overkill it. Why do students find this one hard? I guess the words. There's a lot of words in there. But I'll try to decode the words and hopefully you'll find them okay. They find it also hard because it's lengthy. It might take us 2 pages. Don't worry, it's the same steps every time. Is that okay? Again, think of stat points, points of inflections, nature, graphing. That took a page and a half. But as long as you know the steps, it was okay. This is going to be the same thing. Okay? And a little bit of logic. Because it is a real life problem. So it's not like just a generic theoretical math, it's applied math. So you've got to have a bit of logic, you've got to use your head here a bit. So it does help if you have savings for yourself, or if you understand a little bit of savings or anything like that. Yeah, that's what I said, but we're going to not in standard math. In standard math, you really need to know the words. Here, it's actually just going, I just need this, this, and this. Because it's more algebra. That's what advanced is. So I know what you're saying. That's what I mean. I'll try to remove from the words. See, the students that have always struggled with this are the ones that haven't understood. It's got nothing to do with the words. They just don't understand them. They just keep reading it and going. It's just like, it's not about the words. It's about that. So let's see. Investing money by regular installments. Investing money regularly into an account like superannuation is a more complex example of a geometric series. Therefore, to find what regular equal contributions will grow to over a period of time, we can use the geometric sum formula by the contribution. So that's the formula we're going to use generally. Right? You're going to see that that's the formula you should be aware of already. Not the P, but you should be aware of ARN minus 1 over R minus 1. That's the sum of your geometric. We're just going to get straight to an example. That's just how these work. Okay, before we start, do you guys know what a superannuation fund is, or what a superannuation is?
Your employer pays like 5%
okay.
to the super, and then rates interest over the years after you retire, you have access to it.
Pretty much, it's a savings account that is automatically paid. Like you said, 5%, 10%, should be around
5%.
12. Fair enough. Okay, there you go. You can choose. Savings account for your retirement. Why did they create that? Because they realized that a lot of people are not saving for their retirement, and therefore, once they came to retirement, a lot of people were dependent on the pension to the seniors, right? And that takes a lot of strain on the taxation system. So they created superannuation, so you're funding your own retirement. The good with super is, as you're putting money in, every year keeps growing. So it's a good savings account. You can't touch it, obviously, until you reach. Right now, I think 66. No, I think it's 67 now. And I think by the time you guys probably retire, I'll probably be around 70, 72. Because as years are going on, we're getting healthier. So that, and so on. All done by math, numbers, and then they just tell you this is the year now. Anyways, or I guess from a government point of view, if they can make you work more, they make more money. So don't forget that. It's out for more than, not both. Don't you? A man invests $1,000 at the end of each year into a super fund, which pays 12.5% compounded annually. Calculate the value of the investment at the end of the 30 years. So every single year he puts in $1,000. Every single year it grows by 12.5%, and he's doing that for 30 years. Let's see if you guys can understand this. Ready?
It's not for every.
Sorry?
It's not for every.
What do you mean?
The first year doesn't get interest.
No, there is.
Is it?
Yeah, the first year. Well, why would you say there isn't?
Because at the end of the year.
Yeah, but he's also his investment goes at the end. You're getting into it too much now. But I get what you're saying, but you see it already wrong because you're getting too much into the words. I know they do that. Just don't worry too much. Okay. Because if I put in $1,000, just so you understand, if I put in $1,000 December 31st, by December 31st next year, didn't it grow? Okay. So don't think, if I put in January 1st, by January 1st next year, didn't it grow? Does it really matter when I put it? Okay. It matters when I put it January 1st, I take 31st of next year. That's how I think of it. I think December 31st is the same as January 1st of next year. Does that solve your problem? So then don't think like that anymore. Just, yeah, that makes sense. December 31st is January 1st of the next year. Easy. Question? You get that, what I just said there? Yeah. Girls, you understand what I meant by that? Okay. A1. A meaning amount. Just like you learned before with compound interest. 1, that means after the first year or the first period. A1. How much will I have after the first year? Well, 1,000, very close, times 1 plus 12.5%, because it's always going to be compounded. Always. And equals. Simplify these. All I'm going to plug into my calculator, that to get that number. So I plugged in the bracket and I got this. You don't want to write really percentages every single time. Do you feel like you can do that as an A1 every time? That's good so far? Okay. A2. Can you just give A2 is, again, the amount after the second year? Do we all agree? What happened then? At the end of the first year, you earned interest, and then what are you going to do? Pause. Think about what he just said. At the end of the year, at the end of the first year, what happens? You grew some money, it grew, and then you didn't grow some money, but it grew, and then you added another $1,000 because you're putting in, a man is investing 1,000 at the end of each year. That means in the second year, what would have happened? It would have been the amount you had in A1 plus 1,000. Good. Make us 12.5. And then I like to say it grows. Think of it like that. So A1 plus 1,000, and then it grows. Grows is this number. 1.125. 1.125. It grows. So far, I've been at A1 What's A1? A1 is 1,000, 1.125 plus 1,000 in brackets. That's all multiplied by 1.125, expand. That becomes 1,000, 1.12. Here, students who don't like this, right, are the ones that already don't like algebra. Oops, did I put too many ones here? Yes, I did. Okay. 1.125. Again, pause, logic. Can someone tell me how come that makes sense? To me, maybe. How does those numbers make sense? Why it doesn't or why it does? It does. Yeah, so then how? How can you just go, yeah, that makes sense? Yes, that's what I want to hear. Keep going. Go.
Every year that when you add 1,000, it's whatever has grown plus that is growing.
So the way I see it, yeah. So I see it as I put in first $1,000. I put in my first 1,000. How many years did that grow for? 2 years. The second 1,000 I put in, how many years did that one grow for? So you can see the math is actually working out. Let's do A3. You have to get up to A3. Must. A1, A2, A3. Okay. A3. Nikki, what do you think A3 is going to be? Isn't A3 going to be A2, A2 in your second year plus 1,000? You're going to put another $1,000 in and then it's going to grow. You're going to earn some interest. What's A2? A2 is all of this number.
Do you have to show working out for the first 3 years?
Whatever I'm showing you is exactly. I never show you more, I never show you less. I just show you just enough. Okay, how come that makes sense? Again, the first one you put in, what happened to it now, Nikki? If after your third year, the first $1,000 you put in, it grew for how long? 3 years. Do you remember your compound interest formula was A equals P bracket 1 plus R to the power of N? Compound years, work it out. Wouldn't you have just gone put $1,000 to power of 3? That's how much you made after 3 years. That's how much your investment is worth now. That's what you would have done back in like year 9 and year 10. So that number there that I just wrote up here is the same as that number. 3 years. And then what about after 1 year? So the first one you put in grew for 3 years. The second one you put in grew for 2 years. The last one you just put in at the beginning of the year grew for the 1 year only. Think of your parents. You guys will be 18 next year, right? Think of them, if they put $1,000 for you, the first year would have grown for 1 year. The second year, the first one they put in would have grown for 2 years. Then the second year, whatever they put in would have grown for 1 year. Now think of when you're 18. The first one they put in would have grown for the first one they would have put in, if you're 18, would have grown for how many years? 18 years. The second one would have grown for your third birthday for the 10th birthday, it would have grown for 8 years. Your 15th birthday, it would have grown for 3 years. Your 17th birthday, it would have grown for 1 year. Can you see? So hopefully, yeah, it's working it right. So it makes sense. Okay, once you've got A3, you can generalize now. It says calculate the value of 30 years. Obviously, you're not going to keep going like A4, A5. You're going to just now write A30. Now, I do have more space, right? We don't decrease. So you see how it says, so maybe I should go back up. You see how it says it's decreasing, 3, 2, 1. My powers don't decrease. You want it to always increase. So I'm going to start around. So all you do is you write this at the beginning, 1,025 plus 1,000, 1.125 squared plus 1,000, 1.125 cubed. You won't get it wrong.
Oh, that would be the first.
Yeah. Let's just say that. Why do I do it like that? Yeah, that's a good question. Yeah, no, seriously. Because I guess, yeah, that's just just to make sure I can reduce any errors you guys will make. So always increasing. Because when you're looking for your pattern, you don't want to look for a increasing pattern. Now we're going to go A what? 30. That's now it's so much easier. This one is 1.125 plus 1,000, 1.125 squared plus 1,000, 1.125 to the power of, what's your last one going to be? 30. Which again, Nikki, does the first one, just so you know. The first one you put in, after 30 years, it would have grown 4. The second one you put in would have grown for 29 years. The third one you put in, 28 years. Do you see the logic of that? Okay. Now we find a series. So we don't have a series yet. They come from your brackets. So what you got to do is factorize 1,000 out. Factorize 1,000. (1.125) plus 1.125 squared plus ... plus 1.125 to the power of 30. Can we all see that? This is a GP. There is no APs for loan or superannuation. It's all about GPs. So what's the sum formula for a GP? Do you guys know it by any chance? S of n equals A. I'll write it here. A r to the n minus 1 over r minus 1. Rings the bell? Say it again? It's right here. What is A equal to? What is A equal to now? Part of my sequence. Which is what in this case? Tell me.
1,000.
No, that's not your first term. That's 1,000 multiplied by a sequence. Yeah, this is your sequence. That's why we took out 1,000. Otherwise, if you don't take out 1,000, you actually don't have a sequence. Because it actually count. Yeah, A is 1.125 times R. What's R going up by? Yeah, 1.125. 1.125. Do you guys remember how to find R? To find R, it is the second term divided by the first term. The second term divided by the first term. So it's just 1.125 squared, which obviously I think I just memorized. It's just the bracket. We see that, Nikki? Can you see it's just, imagine this was x plus x squared plus x. What's going on? X. So 1.125, 1.125 squared. It's just going up by 1.125. How many terms do you have? What's your n equal to? Minus 1. A lot of brackets. Over 1.125 minus 1. Now it's just calculator time. And we're done with this question. Not bad. You only put $1,000 in. That means after 30 years, you've technically only used 30,000 of your money. What happens after 30 years? That $30,000 has grown to 300,000. It's not realistic. Why do you say that?
Because who's going to give you a right back?
12 and a half. True. If you don't know finance and you're not a person, if you're the general population, yeah, you probably, the best you can get is around 4%. If you really know what you're doing, like general population. Someone like me who does a lot of this stuff, I would say you can get around 8% to 15%. Compound, correct.
On the bank.
No.
You see it from the stock market thing.
Correct.
You have to do that.
Yeah, it has to be like stocks and stuff like that. It has to be international. It cannot be banks. Banks, you're going to get like 0.5%. 0, like it's bad. You're just losing money to the bank today. And I think that makes a good point with like, everyone that says like when do you use this in the world, or how am I going to learn this, whatever. It's like, and I've always responded with the same comment. My response to that question is, those who know math use math. That's it. If you don't know math, you're just going to be general population. So this is a good one to know. You're right. If you're interested in it, we will do some exercises with the stock market on this topic because I like to, and you guys can see what happens if your parents, for example, even had invested for you guys at 18 years old. We'll actually go look at the last 18 years and see how much money you guys could have made.
I would have been stock.
Then maybe I must have done it wrong. One of us is wrong. Did you guys double check it? Power of 30 minus 1. No, I'm right. I don't know. Let's have a look. It's funny, right? Slide in the back, that's the issue. What did you do wrong? Doesn't look like anything. Oh, there. Bracket. Look how much brackets I've used there. I used another bracket. You didn't.
Oh, okay.
You guys got it? Good job. All right. All good? Girls? Let's do another one. Everything.
Nice.
Yeah. Everything. For now. Good. And we go again. As you can see, there's not really on the textbook questions. Just straight, you just start. That's why I said I think we should just do these. Because these take a little while to master. A superannuation fund pays an interest rate of 8.7, which compounds annually. Stephanie decides to invest 5,000 in the fund at the beginning, commencing 1st January 2003. What will be the value of Stephanie's super when she retires on 31 December 2023? You see, this is what we're talking about. But how many years is that? From 2003 to 31 December 2023? Sorry?
23.
No, 23.
Just one.
No, it's 2003 to 2023. 20.
Oh,
Yeah. But this was on 1st of January. This is 31st of December. So really, what should you have used this as? Yeah, right. I'm trying to say, make it simple. 1st January 2024. It's the same thing, isn't it? So how many years is it really?
22. Oh, sorry.
21. 21 years. From 2003 to 2024.
Oh.
That's where your teacher's teaching you on and whatever. But why? Why complicate it like that? Why don't you just think of it like I just did? Am I wrong? Like you've learned now, Giovanni. You've also learned it, Aiden and stuff like. You teacher would have probably said. They probably would have emphasized, hey, be careful. Because at the beginning, at the end. Yeah, but like you can like that because. But you're putting it the first of. Just put it on the 1st of January the next year. It's not going to kill you one day. You're definitely not going to earn any more interest. So you might as well just do it one extra day. Let's start. A1 equals, I put in 5,000, 1 plus 8.75%. We simplify the bracket. 1 plus 8.75% is 1.05. All good so far? A2, who wants to try it? A2, try not to look back.
5,000. A1 plus 8.75.
Say again.
5,000 A1 plus 8.75.
You got the right logic. You meant to say this. A1 plus 5,000, 5,000 all ones. Because you're saying 5,000 A1, that's like whatever A1 was, let's call it 10,000. You're saying now times that by 5,000. Much. It's whatever I had, 10,000 plus 5,000. True? So A1 plus 5,000, and then you said plus interest, which means to me, you get the logic of it, you're plussing, but it's not plussing interest, you're multiplying by the interest. And then it grows. So I get it, like in your head, you got the right logic, it's just you're saying it wrong now. Now you just gotta get the wording out right. So A1, the amount I had yesterday, literally, the amount I had yesterday, plus the amount I put in today, and then it's got to grow. And the grow is 1 plus from your compound interest formula. That's why it's 1 plus R. This becomes 5,000, 1.0875 squared plus 5,000, 1.0875. Can we see that? I didn't want to substitute it back in this time. Can you just see if I had this number multiplied by this number, what happens? This number multiplied by this. Isn't it just going to become squared? And then what's this times this? Right there. So you can start seeing, you'll realize a pattern eventually. Does the logic of it make sense? Let's think about it again. If I put in 5,000, it would have been power of 2. Then yesterday I put another 5,000. Well, that would be for 1 year or for 1 day, whatever. Makes sense, doesn't it? Okay, good. Done. A3. A3 becomes, try it one more time.
A2
A2, the amount I had yesterday, plus
plus 5,000
the amount I just put in now.
times.
Good. You're getting it done. It's going to always be like that, even for the next topic, loan repayment. Good. And then without me substituting A2, if it's okay with you guys, I'm not going to substitute that in because that's when it gets really messy. Can we assume what it's going to be? It's going to be like 5,000, 1.0875 to the power of 3 plus 5,000, 1.0875, 2 plus. Good. Aiden Larson, you guys are quiet. You're going good?
Yeah.
What did I say just before you accept that? Flip it. I don't like it that it's decreasing. Make it increasing. So rewrite. And since, it's okay with you guys, since we know we're about to increase and we know we're about to factorize, why don't you just do that in one line? Save time. 1.0875 plus 1.0875 squared plus ... Always 3 dots, minimum. 1.0875 to the power of 3.
What's the point of dots?
What do the dots mean?
No,
Oh.
what's the point of this one?
We wrote dots before as well. Dot. Sorry. What am I missing?
Because you know it's the power of 1 to the power of 2 to the power of 3.
Thank you. I understand what you're saying. Sorry. I was thinking of 21. A ... A what? Now, how many years?
21.
It's just your hand, right? Your hands just got to get used to this. Repetitive.
Yeah.
And obviously I can't make it any harder. This is HSC. So this is what you'll get. It's just that you've got to be comfortable with the math. Power of 21 equals. Anyone remember the formula?
D times A.
Don't worry about the P so much because P, don't worry, that's P there. That's not a problem. P is just any principal, this amount here. But you can't technically use that formula without breaking it down. I was just trying to say, like, you always will get there. A bracket Rn minus 1 over R minus 1. Exactly the same. Good. So what's your A? What's your first term? 1.0875 times. What's your R? 1.0875. 21 minus 1 is wrong. What you got to do is leave this in brackets. That. So double brackets over R minus 1. Plug it into your calculator, and we're done. $299,604.86. I just saw your life is short and so am I. Oh, God. What's he doing? Happy? Good. 4 marks. But then again, when you compare these 4 marks to like stat points 4 marks, you're like, well, those are a lot easier. But this is just, once your hand gets used to it, it took me about, I don't know, 3 or 4 days to just get my head around it, the steps. And once I did, I was like, yep, pretty straightforward.
I forgot for it, so you can check.
That's it. That's right. Can we, I'll give you a call now.
That's all.
You didn't do it now,
No, so
Yeah,
Could have with someone. I was waiting for you to tell me.
Yes, yes, thank you. Will do. Thank you. All right.
That is true.
Make sure we've answered the question. What will be the value? The reason why I said make sure we've answered the question, sometimes you might just say, how much interest did you earn? Let's say. Or you got to work out, if you put in 5,000, that technically you put 5,000 times 21. You put in 105,000. So the amount of interest you've earned, you've got to subtract from 299. So just make sure you answer the question always. What do you want to do? One more? One more. Go ahead. A person wishes to retire after working for 30 years. Superannuation, how much should be invested? Or this time we're doing the other way, so I'll rather not do that. Hold on. Let's do this one here. Question 1 of your homework booklet. You still need somebody to write it in here.
mathematical table.
Oh. Yeah, explain it to us. Yeah, and you missed out. Because, okay, so what's gonna happen is on Tuesday, the day before the assessment, there's gonna be, like, the whole entire period, like, 4 periods, we're gonna do like a math workshop.
Oh, that's disgusting.
And then we have to answer a book, and the book is also being marked, and the next day we do tests on the stuff that we learned. There's like 60 series long, straight or
So gay.
oh.
Okay, you can get started. Sorry. Question. So 6, if you want to see it, then it's on the screen. It's on S6. We can start with A1. Who wants to try A1? Well, let's do one step a person. Fair enough? We'll start from Giovanni, we'll get to Aiden, girls, and the last one. So, Giovanni, A1,
800,
2,800,
bracket 1 plus 1%,
9%, which pretty much becomes
1.9.
1.09. You could have skipped the first line and just written 2,800, 1.09 if you knew. Good. A2, Aiden.
Bracket A1 plus 2,800.
I love that you said bracket. That means I know that when you're going to write in your exam, you're also going to be writing bracket first. So good job for saying that. Multiplied by?
Bracket 1.9.
Yep, beautiful. A1 is obviously right there, so it should become 2,800, 1.09 squared plus 2,800, 1.09. A3.
Can we skip that step as well? Writing A1 plus.
Actually can't. Yeah. Because we know most students will eventually memorize the patterns, but we don't know if they actually understand the logic of it's the one before plus the today's and then those. So that's really what's happening. All right, A3.
Bracket A2 plus 2,800. And then bracket 1.09.
And what does A3 mean again? It means the amount you have after 3 years, pretty much, right? So that becomes 2,800, 1.09 cubed plus 2,800, 1.09 plus 2,800, 1.09. Then, Nikki, what do you mean to do after this particular step?
You meant to reverse the order.
Good job. Reverse the order. 2,800.
Oh, are we gonna
Right, at the same.
yeah.
Now, I haven't been saying this for the other ones because we were starting off, but personally, I 2,800. What else do you guys say is common?
1.9.
So I'm going to do that. So every time you're going to see me from today, now onwards, you're never going to see me just factorize 28. I'm going to factorize anything that's common. So it's going to look like this. 2,800, 1.09, open big brackets, let's say. Then you're left with 1 plus 1.09 plus 1.09 squared only. Sounds good? Same stuff. So it's up to you. You pick which one you want. Just me, I usually do this version.
Would your first still be 1.0?
No. What's your A now? 1. That's why I choose this.
Okay.
All right. Dot, dot, dot. A. Last one.
35.
A 35
2,800.
equals
Bracket.
2,800. Bracket
1.11
1.09.
plus 1.11 squared.
1 plus 1.09
Dot.
plus
1.09 35.
incorrect. If this was a 3 and this was a 2, that means if this is a 35, what would the last one be? 34. That's how you do it. That only happened because I'm doing it by me factorizing 1.09 out. That's what happens. But it's good for you guys to see that, because maybe your teachers or exams or whatever you read, you might see that, you're like, wait, what happened? But that's all. But how many terms are you still going to have, Nikki? How many terms do you have here? 1, 2, 3. Can you see you have 3 terms? Even though it says power of 2, you still have 3. Why? Because you're counting from 1, then 2, then 3. 1, 2, 3, 34, but you got plus 1 more. Yeah, plus the 1 as well. So there's 35 terms still. So your power is still 35. So it's like you know it, but you guys are used to reading the last term as just 35. This one's going to be 34. It's going to be 1 less because you factorized 1 out already. Can we see that happening?
Sam,
Up to you guys, but yeah.
you know, A is like 35.
A of 35.
What are they?
The way of reading it is this is A1. This is A2. This is A3. Dot, 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 all the way to A35.
Do we need to?
Just do it. Look, do I need to? Will you lose marks? No, definitely not. Will it make you look good? Yes. So therefore, if I'm marking it, all I know is your student number. I'm looking at your marking and you're working out. I'm like, okay. And then I look at another mistake. I'm like, okay. So should I give her a 2 out of 4, a 3 out of 4, or a 4 out of 4, or 1 out of 4? This is a poor student. I'm going to give him probably a 2 or a 1. Oh, wow. Like she even wrote dot, dot, dot. So, or this person wrote dot, dot, dot. That means they're a top student. I'm probably more leaning towards a 3 now. Okay, did I do a serious mistake? No, it's a 4. Like, do you get what I'm saying?
Okay.
You got to understand, all we know at the HSC when we're marking is a number. That's all you are. So your working out is everything to us. We don't know who you are. We don't know what school you came from. We don't know nothing about you.
So they're very flexible in marking based on how good.
HSC, it's marked in the opposite way to the way your schools are. You start off at 0. I keep saying that, right? You guys are not, like your question when your teacher's going to mark, it's going to be 0, and then going to go, okay, 1 mark there, 1 mark there, 1 mark there, and yep, this line, 1 mark there. That's how your teachers are going to mark, right? At HSC, we don't mark like that. It's this person's already got a 4. It's 4 out of 4 already. Did they lose a mark? So we go through it. Their marking now it's correct. Everything's right. They changed 2,800 to 2,500 by accident. They're working out flawless. Otherwise, is it a 4 out of 4 or is it a 3 out of 4? Oh, we'll give them a 4 out of 4. Does that make sense? So you start off actually at full mark. You get deducted marks. At school, you get awarded marks. Different strategy. Okay, good point. So yeah, you won't lose marks. It's just how you want to get perceived. So you can assume extension students are going to be writing it. So therefore we know already, we'll know, you'll be surprised with the amount of papers we see. A long time ago, the amount of papers we see, you'll know straight away if this person's a low advanced, a high advanced, or even an extension. You just know from their working out. So I'm trying to get you guys to that extension level. So then that way you're not disadvantaged when we're marking. Just same as English. Your first paper, standard or advanced, you're all going to get marked as advanced. Whether your teachers tell you or not, that's the truth of it. So that means when you're writing, if you're at a standard level, you're writing at a standard level, it'll show. That means you need to write at a advanced level. Doesn't matter if you're standard, because you'll know, like when you just read it, you'll be like, standard. So therefore, that's when you get scaled down. Make sense? Next line. Equal. I think we're back to you, Giovanni. 2800. 1.09 and then A. What's A?
1.
And you guys can see now, right? This is my series. Where else? That's why we have to factorize it out. A is 1, so that's why I do it like this, because then I don't need to worry about 1. What's R now?
1.09.
1.09. What's your N?
34.
If you're wondering why it's not 34, I'll say it one more time. This is 1. Power of 1. 1, 2, 3, 4, all the way to 34. How many terms is that from here to here? 34. But then you got plus 1 more. True? Because you're starting off at 0, so 34. Rn minus over. Get into your calculator. Well done. Okay. Since we're here, I'm going to now. I'm going to show you find AN, because I will and they will. So just put it in, quickly do it. 0.0935 minus 1 divided by 0.09 times 2800 times 1.09. $58,349.22. It's a lot. It is a lot. So if you think about it, if you're 18, if you start when you're 18, 5 years, you'll be 53 years old. You put in 2,800 times 35. You put in about just under 100,000. You made 658,000 for your retirement. So it's good. Obviously, it's for your retirement. That means a long time. All right. N meaning any number of years. What if I work out like 40 years, 20 years, 18 years, 17 years? I want to make a generic formula. So it's going to look like this. Let's see if you guys agree. Yeah, let's see if you guys agree. 2,800 bracket 1 plus 1.09 plus dot 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 plus 1.09 to the power of, think of what I said up here to Larson.
N minus 1.
1 before n. 1 before n. N minus 1. Then we shall get this. A R N 1 over R minus 1. Easy. Now I'm going to do a few more lines just to show you how we can make it into a 9900. So right now, these are all band 6s. Okay, so that's good. That's the nth term. You can see you can sub in n is anything. N is 35. It looked like the one we wrote above. True? Nikki, you can see that as well. N was 35, just plug it in. So you can tell our formula's right. Now you can just do a bit of algebra. That's it. That's the hardest questions you'll see. So once you're here, what do you know? You know 2,800 times 1.09 is 3,052. 1.09 n minus 1, that becomes 0.9. 0.09. So far, so good. Okay, but I also know that 3,000 divided by 0.09 is Yeah, I'll probably leave it as a fraction, is 105,200 over 9. Oops. Let's leave it at that.
That must be confusing.
Yeah, I know. That's why I'm doing it. 3,052 divided by this. Plug it into your calculator. It will give this. And that's it. So all I'm doing is actually simplifying. For some reason, because these numbers look very large, a lot of students actually just go, I can't do this. I don't get what's happening. All I'm really doing is just simplifying everything that's on the outside. This and this. Did you get it out? Giovanni? 3,052 divided by 0.09 should become this. Why not?
Oh, yeah.
What do I mean? SD,
Oh,
of course, right as a fraction. So that's all, there's nothing fancy. But that's how you can make them hard. That's hard. Okay. Still one more? Or should we do loan repayments? Very similar. Loan repayments and then we'll see. Let's do that. Okay. Let's stop that.